The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. First of all, I want to apologize for not posting the videos in a timely fashion. I got distracted after my last class and completely forgot about it. But anyway, they are there today. Thankfully, one of you emailed me and said, hey, where are the videos? So again, sorry about that. Now, we're going to go on to section 2.4, part 1 today. But before we do that, a student had a request. They said, how do you find the LCD of 3 or more fractions? So I'm going to do a few examples of problems that take us back to section 2.2. And here is the first example. 5/6 x plus 2/9 equals 1/3. So our denominators are 6, 9, and 3. To find the least common denominator of all the denominators, the first thing we do is the prime factorization of each denominator. 6 would be 2 times 3, 9 would be 3 times 3, or 3 squared, and 3 is prime, so the prime factorization would just be 3. To find the least common denominator, we take the product, that is to multiply, the product of the highest power of each different prime factor present in all the denominators. So let's take a look. We've got what? A 2 and 3s. The highest power of 2 there is just 2 to the 1 power. The highest power of 3 is 3 squared. So 2 times 3 squared, 2 times 9, 18. So the LCD is 18. Now, how would we use that in this problem? We would take the problem and we would multiply both sides of the equation by the LCD, which is 18. Distributing on the left, we get 18 over 1 times 5/6 x plus 18 over 1 times 2/9 equals 1/3 times 18 over 1. Then going back and reducing each product, 18 over 6 is 3 over 1. So we get 15x plus 18 over 9 is 2 over 1. So plus 4 equals 18 over 3 is 6 over 1 equals 6. So we found the least common denominator by starting with the prime factorization of each denominator. We cleared the fractions. Now, going on and solving the equation, 15x equals 2, divide by 15x equals 2/15. Let's take a look at one more example. Let's see here. We've got 1/15 x minus 4/5 equals 2/3. So again, to find the least common denominator, we're going to do the prime factorization of each denominator. The prime factorization of 15 is 3 times 5. 5 is already prime, 3 is already prime. So the LCD would be the product of the highest power of each different prime factor within all the different denominators. We have 3 and 5. 3 to the 1 power times 5 to the 1 power. 15 is the least common denominator. So we come back here and we multiply both sides by the least common denominator, distributing 15 over 1 times 1 over 15x minus 15 over 1 times 4/5 equals 2/3 times 15 over 1. The 15 is reduced down to 1 over 1. 1 times x is x, minus 15 over 5 is 3 over 1, so minus 12 equals 15 over 3 is 5 over 1 equals 10. We've cleared the fractions. Add 12 to both sides, x equals 22. Anyway, so there we have the process, how to find the least common denominator, and then how to use that to clear the fractions in an equation. With that, we're going to go on to section 2.4, part 1. We'll spend today as well as Monday on this section. And this is all about formulas. So this problem says, Valentine's Day. Find the markup on a dozen roses if a florist buys them wholesale for $12.95 and sells them for $47.50. So buy, sell. So what is the markup? How would you find the markup? Well, you would take what? The selling price minus the buying price. Okay, so we've got what? $47.50. Oops, 50 minus $12.95, and we get $34.55. So that is the markup to the selling price or from the buying price. Anyway, let's take a look at another example. This says savings. A man deposited $5,000 in a credit union paying 6% simple interest. How long will the money have to be left on deposit to earn $6,000 in interest? Since we're dealing with simple interest here, we'll use the simple interest formula, which is I equals PRT, where I is the interest earned, P is the, the principal, that is the amount invested, R is the annual interest rate, and T is time in years. Okay, so a man deposited $5,000, that's the principal, paying 6% simple interest, that's the interest rate, which we have to convert into a regular number. Okay, let's see here. How long will the money have to be left on deposit? So that's the unknown time to earn $6,000 in interest. So putting the values we have into the formula, we get $6,000 equals $5,000 times 0.06 times T. So the first thing I would do next is I would take the 5,000 times the 0.06. So 5,000 times 0.06, which gives us 300, that times T. Then we'll divide both sides by 300. So T equals, let's see, we could divide out of 10, divide out of 10. 60 divided by 3 is 20. Now, let's see here. This would have been dollars. So T would be 20 what? 20 years. Any questions on that problem? Okay. Here's another one. It says air travel. An airplane flew from Chicago to San Francisco in 3.75 hours. If the cities are 1,950 miles apart, what was the average speed of the plane? So this is distance equals rate times time. Again, D is distance, R is rate, rate or speed, and T is time. It says an airplane flew from Chicago to San Francisco in 3.75 hours. If the cities are 1,950 miles apart, what was the average speed? So the rate would be the unknown. So D equals RT becomes 1950 equals R times 3.75, or we could say 1950 equals 3.75 R. We'll divide both sides by 3.75. So we've got, let's see here, 1950 divided by 3.75. And that comes out to be 520, and that would be miles per hour. Any questions there? All righty. Here's another question. It says, metallurgy. Change 2,212 degrees Celsius, the temperature at which silver boils, 2 degrees Fahrenheit. Okay, so we want to change from Celsius to Fahrenheit. It says round to the nearest degree. The formula for that is Fahrenheit equals 9/5 C plus 32. So we get F equals 9/5 times 2212 plus 32. Okay. So we've got 9 times 2212 divided by 5 plus 32. And we get 4013.6 degrees Fahrenheit, but it said round to the nearest degree, which would be right there. 5 and above rounds up, 4 and below rounds down, so that's going to round up. So it's going to be 4014 degrees Fahrenheit. Any questions there? Okay. All right, now we're going to look at some formulas, and we're going to take the formula and solve it for a given variable within the formula by using addition, subtraction, multiplication, and division properties of equality. So first of all, we've got this. P equals R minus C, and we are to solve for R. So we want to write the formula such that R is all by itself. Well, if I add C to both sides, I get P plus C equals R. Oops, I should have written solve for R. So we've solved this equation for R. Any questions about that? Okay. Let's see here. A plus B plus C equals 180. We are to solve for A. So I need to get rid of B and C from the left side of the equation. So I'll subtract B and I'll subtract C. So A equals 180 minus B minus C. Any questions about that? All right. Here we are to solve C equals 1/7 RT for R. I want to point out, I may have mentioned this before, but I'll mention it again. If a variable is a lowercase letter, that's a different variable than if it's a uppercase letter, okay? So capital R and lowercase r are not the same thing. If WebAssign uses a lowercase and you write your answer with an uppercase, it's going to mark it wrong. So pay attention to the cases of the variables. Okay, solve for R. Well, to get rid of the 1/7, I'm going to multiply both sides by 7. So I'll get 7C equals RT. Then I'll divide both sides by T, and I get R equals 7C over T. Let's see here. D equals RT. Solve this thing for T. We'll just divide both sides by R. So T equals D divided by R. Let's see, here we've got Y equals MX plus B. Solve this thing for X. Well, now things are a little more complicated. Remember that mantra, isolate the variable term, isolate the variable. Well, in this case, the variable of interest is the X. So this would be the variable term. So to isolate the variable term, we would subtract B from both sides. Then to isolate the variable, we would divide both sides by its coefficient. M is the coefficient of X because M is being multiplied by X. So X equals Y minus B all over M. Let's see here. A equals P plus PRT. Solve for T. Again, this is the variable. This is the variable term. So first of all, to isolate the variable term, we'll subtract P from both sides. A minus P equals PRT. Then to isolate the variable T, we have to get rid of the PR. So we would divide both sides by P times R. That would reduce down to T, and we get A minus P over PR. Let's see here. 3x plus 4y equals 20. Solve for y. So this is the variable. This is the variable term. So to isolate the variable term, we'll subtract 3x from both sides. Then to isolate the variable, we'll divide both sides by the coefficient of the variable. So I get negative 3/4 x plus 20 over 4 is 5. Now, you might be asking, why did I do it this way? Why didn't I, let's see here. Let's go back here. When I subtracted 3x, why didn't I write it that way? And when I divided by 4, why didn't I write it like that? Okay. Now, there's nothing wrong with this form. However, when we get to chapter 3, we're going to be looking at something called the slope-intercept form of an equation. And we'll take an equation and we'll solve it for y, and we'll put it in this form, where we'll have the variable x term first, followed by the constant term. We'll talk more about that when we get to chapter 3, but I'm just trying to introduce that idea early on. Let's look at another example of that. If we have 5x minus 6y equals negative 12, and again, we want to solve for y. This is the variable. This is the variable term. So we'll start out by subtracting 5x from both sides. Then we'll divide each side by negative 6. Negative divided by negative is positive. And again, negative divided by negative is positive. So there we have y equals 5/6 x plus 2. Okay, let's see here. This says f equals 7n times d plus dz. And we are to solve for z. Wow, life just got complicated, didn't it? Well, it looks like I've got a couple of options there. The question is, should I distribute the 7n or should I divide it out? You know what? Let's try it both ways and see what happens. sometimes one way works better than another. So I'm going to start off by dividing both sides by 7n. By doing that, I get that. Okay. Then let's see. Oh, and let's go back here. This is the variable and this is the variable term, right? So now to continue to isolate the variable term, I would subtract d from both sides. So f over 7n minus d equals dz. So now I've got the variable and the variable term. It's time to isolate the variable. So I'm going to have to divide both sides by d. So I got z equals f over 7n, excuse me, minus d, the whole thing over d. Wow, that's just really messy, isn't it? It isn't necessarily wrong, but it's, like I say, it's really messy. Let's try a different way of doing this problem. Okay, so let's go back. Let's see, where was it here? F equals 7n times d plus dz, and we are to solve for z. This time, let's distribute first. So we're going to take 7n times d, so 7dn, plus 7n times dz, 7dnz. And again, if you've forgotten, when you're writing a term, you want to put the letters, the variables in alphabetical order so that it's easier to identify which terms are like terms and which ones aren't. So now, again, let's see here. This is my variable. And at this point, this whole thing is my variable term. So to isolate the variable term, I'll subtract 7dn. So f minus 7dn equals 7dnz. So now to isolate the z, I'll divide both sides by 7dn. So z equals f minus 7dn over 7dn. Now, that's equivalent to this, but a lot cleaner, so to speak. So in that case, it was better to distribute. Let's see here. Here's another one. Capital F equals lowercase f times the quantity 9n minus 1, and we are to solve for n. Well, let's see. Last time it worked best to distribute first, so let's do that and see what happens. F equals 9 lowercase fn minus f. I'm trying to solve for n, so there's the variable, there's the variable term. So I'm going to add lowercase f to both sides. Big F plus little f equals 9 little fn. Divide both sides by 9f. 9 lowercase f n equals big F plus little f over 9 little f, or lowercase f. Okay, well, that's all I have for you for today. As I say, we'll spend 2 days on this. So tomorrow we'll come back and spend some more time looking at formulas and solving them for a given variable, as well as some applications. I will be back at 1:15 today with an office hour. So if you should have any questions, feel free to come back then. I'm going to go ahead and stop the recording now.